This lesson concerns ellipses. Before you study this lesson, you should have already had some experience with the equations of circles. The first thing we're going to do in this tape is look at the definition of an ellipse, and we'll see then what the equation of an ellipse looks like when it's in standard form, so that we can easily sketch a graph of the ellipse and find some of its major parts. In this particular lesson, we're only going to deal with ellipses whose center is at the origin 0, 0. So this will get you the basics concerning ellipses, and then it's a simple matter of using what you know about transformations of functions, where you translate your axes to a new location to graph more general ellipses. Let's look at the definition. Is the set of all points in a plane for which the sum of the distances from two fixed points called foci is a constant. This may seem like an unusual definition for you, but let's talk about the definition of a circle before we explore this idea of an ellipse a little bit further. The definition of a circle is something like this. A circle is the set of all points in a plane for which the distance from the points on the circle to a fixed point called the center is a constant. We know that every point on the circle is the same distance away from the center of the circle, and of course that distance we call the radius of that circle. Here we have two fixed points in the plane called foci, and we're finding points so that when we add the distance from the given point to these two fixed points, we always get the same number. That's what we mean by it being a constant. Now I have a little model here to show you what we mean by this definition. I have pictured here an ellipse. These two markers here are representing our two fixed points that we refer to in the definition as being foci. So we have these two fixed points here called foci. Now this string is here to illustrate something. Let me stretch this string up. Notice that if I choose this point on the circle where I have this string stretched up right here, let me see if I can get a hold of that. If I compute the distance from this point to this focus and from this point to this focus, and I add those, then let's say I move to another point on the ellipse. Again, I calculate the distance from that point to this focus, from that point to this focus, and I add those. As it turns out, no matter where I choose a point on the ellipse, when I calculate these two distances, I always get the same quantity, the same number, when I add those distances. Even if I choose points down here, if I calculate the distance from that point to these two foci, then I will have that same sum again coming up. And so actually you can use this. This is how I drew this ellipse, was using this string and just stretching it out and tracing around and then letting my string keep coming up. Then notice that the distance that I have this string stretched is always the same. This is always the same distance because this distance here is constant. So as I move, these two distances will change, but their sum will always be the same amount. Now I've used the word focus and foci. Let's talk about that. Focus, F-O-C-U-S, is singular. Foci, F-O-C-I, is plural. In the definition, you'll notice that we used the word foci because we're talking about the two fixed points. Each individual point is called a focus of the ellipse. Now that we've seen this definition and seen sort of a picture in representing what this definition is telling us, let's look at some of the characteristics of an ellipse. First of all, the graph of the equation x squared divided by a squared plus y squared divided by b squared equals 1, or perhaps this form, x squared divided by b squared plus y squared divided by a squared equals 1, with a larger than b larger than 0, is an ellipse with center at the origin. Let me stop right there for a second and let's look back at these equations. You'll notice these equations look almost alike. The only difference is where a and b are located in the equation. Notice first of all we have x squared over a number plus y squared over a number. these numbers must be positive since they're represented by a squared and b squared. And then we have this equal to 1. So this is what we call the standard form of our ellipse. Now you'll notice over here we're assuming a is the larger of the two numbers a and b. A is larger than b, and notice that we're also saying both a and b are positive. If the larger number is under x, we have an ellipse that is elongated along the x-axis, like the picture that I showed you a moment ago. However, if the larger number is under y, then our ellipse will be elongated in a vertical direction along the y-axis. You'll see this as we do some of our equations after a while. One of the things you're going to want to do is to be sure and get your equation in this form, x squared over a number plus y squared over a number equals 1. And then inspecting these two numbers down here, choose the larger one to call a. Our center is going to be at the origin. Now, the major axis will have a length of twice a. The minor axis will have a length of twice b. Now this a and b that we're talking about is coming from our equation. Now we do not have an equation for this picture that I used a moment ago for our ellipse, but let me just put this back up here to talk about a couple of things here. This ellipse, as you can see, is elongated more in the horizontal direction. It's longer this way than this way. So from this corner side of my ellipse over to here is referred to as the major axis. The length of this major axis is 2 times the number a. Now, from this part of my ellipse to up here, this shorter distance across here is called the minor axis, and the length of this minor axis will be 2 times whatever the number b is. So we can get those values from our equation, and they will be very useful for us as we graph our ellipse. The vertices, now that's plural for vertex, the vertices are the endpoints of the major axis, and the foci are on the major axis. Again, if I put this picture back up here, since our major axis is across here, these 2 points where my fingers are would be called the vertices of our ellipse. They're the endpoints of our major axis. Notice I already had our foci marked with these pins. The foci, notice, are on this major axis. Foci will always be on our major axis. Now, we have another piece of information here concerning our ellipse, and that is on finding vertices and foci. Notice the distance from the center to the vertex of an ellipse is a. If you think about what I was talking about a moment ago with our picture, if all the way across this major axis is twice a, and this is the exact center, then from the center out to here would be a distance of a, and from the center over to here would also be a distance of a. So from the center to a vertex is the distance a. Now, the distance from the center to the focus of an ellipse is c, where c is given by the equation c squared equals a squared minus b squared. Now, recall in our equation that we were looking at a moment ago, our equation will contain a and b. There's nothing in here about c. So we will have to remember how we find c. Once we have found c, it's telling us that the distance from this center over to this focus point will be a distance of c. So all we really need to know to sketch a graph of an ellipse and find the vertices and foci is to know the a and the b, and knowing those, find c, and then knowing that a is our larger value. Now let's take this information and we're going to find the vertices, the length of the major and minor axes, and we're going to sketch the graph of this ellipse. Notice this equation. X squared is over a number, plus y squared is over a number, and it's equal to 1. That's exactly the form that we needed. You will want to memorize these formulas that we had on the screen a moment ago, these right here. You'll want to memorize in the sense of knowing what this format looks like, because when you have an equation, then you're going to need to put it in that form if you know the equation is an ellipse. And we'll talk about how we know that here in just a little while. Now, looking at our equation that is in standard form, notice that the number 25 is larger than 9. So our larger number is under x. That tells me that my ellipse will be elongated horizontally like the x-axis. Now, we have been saying that all of these are centered at the origin. I'm going to go ahead and list here that the center of my ellipse is 0, 0. I like to get in the habit of doing that because later on when you get more general ellipses, you're going to want to notice where that center is. So we might as well get in the habit of listing the center. Now, since 25 is our larger number, a squared is 25. If a squared is 25, then a is 5. Recall that a gives us the distance from the center, in this case 0, 0, to a vertex. Since our larger number is under x, and we know that we're going to be elongated horizontally like the x-axis, I'm going to go over here to the origin, and I'm going to count a distance of 5 units on my x-axis. So 1, 2, 3, 4, 5, and I'll put a mark there. That's one of my vertex points. Now I'm going to list here vertices. One of my vertex points is at the point, oops, I just wrote that wrong, at the point 5, 0. Okay? I went over 5. I did not move on the y-axis at all. Now I also from the center want to go that same distance of 5 but in this opposite direction. 1, 2, 3, 4, 5. That locates my other vertex at negative 5, 0. Notice that all the way from vertex to vertex, this is going to be my major axis. How long is that major axis? Well, if I went from 0, 5 this way and from 0, 5 this way, that's a distance of 10. Notice my major axis has a length of 2 times my a value of 5. My major axis has a length of 10. Now, under y, since this is the smaller number, we know that b squared is 9. That means b is equal to 3. And we learned a while ago that the length of our minor axis is 2 times b. So 2 times 3, of course, gives us 6. If we know that our minor axis has a length of 6, that tells us how wide this way our ellipse should be. So from the origin, we're going to go 3 units up and 3 units down. Notice that makes our minor axis a length of 6. And we're simply going to use these 4 points to sort of roughly sketch in our ellipse. Now we're not going to have a perfectly accurate graph here because we're just sort of guessing these points in between, but we want to make a somewhat smoothish type curve using these 4 points as our guideline and sketch in the graph of our ellipse. Now let's see, we have found our vertices at 5, 0 and negative 5, 0. Remember, our vertices are the endpoints of our major axis across here. The length of our minor axis is 6, so we have found the length of the major and the minor axis. We have sketched the graph. Now, sometimes instructors will want you to find the foci. Now, our instructions here did not say anything about finding foci. And if your instructor does not require that, then you can wait on that for a while. In pre-calculus, you will be required to find foci. So I'm going to go ahead and talk about that. Remember on our little fact sheet, it told us that the distance from the center to the focus was c, and we find c using this equation, c squared equals a squared minus b squared. Now, I'm going to write that down up here. C squared equals a squared minus b squared. Now, I remember that by sort of associating that with the Pythagorean theorem. You remember learning c squared equals a squared plus b squared? Well, it's sort of like that, notice, except that instead of a plus, we're doing a subtract here, aren't we, to find c. Well, remember, we've identified a as being 5. A squared is 25. So c squared is our a squared of 25 minus our b squared, which is 9. Well, 25 minus 9 is 16, isn't it? If c squared is 16, then c is 4. C gives us the distance from the center to a focus, and we know our focus is on the major axis. So from the center, I'm going to count off 1, 2, 3, 4. One of my foci is right there, and then from the center for the other direction, 1, 2, 3, 4, my other focus point is over here. So my foci are located at 4, 0, and negative 4, 0. Now, sometimes you can write these points together instead of writing two separate points. In some texts, they will say plus or minus 4, 0. You're to understand this is 2 points, 4, 0, and negative 4, 0. You can do that same sort of thing sometimes with the vertices when the y-coordinate is the same and you're just using a plus or minus here. Okay, so we see that we're going to notice that our equation is in standard form, find the larger of these numbers to identify A, the other number is B. Notice we take the square roots of these numbers to get A and B. And then from that information, we can locate the information we need to sketch the graph. Let's look at this equation. Find the vertices, length of the major and minor axes, and sketch the graph. We have x squared over 4 plus y squared over 16 equals 1. Well, again, this is in that form for an ellipse. X squared over a number plus y squared over a number equals 1. Now, this is very important that I have that 1 over there. You'll notice this time that our larger number is 16, which is under y this time. Since our larger number is under y, I know that my ellipse is going to be elongated up and down like the y-axis. But notice a squared is that larger number 16. So we know that a is 4. The length of my major axis is going to be twice a. So the length of my major axis is 2 times 4 or 8. B squared is my other number 4, so B is 2. That gives me the length of my minor axis. 2 times B, 2 times 2 is 4. Now, I know that my vertices are going to be the endpoints of my major axis. But remember, this time, since our larger number is under y, that major axis is going to be vertical. So, using an A of 4 from the center, I'm going to count up this time 1, 2, 3, 4 to locate a vertex. Down 1, 2, 3, 4 to locate a vertex. And then my minor axis being a length of 4, using a B of 2, from the center I go 2 to the right and 2 to the left. And I will use these 4 points to sketch in my ellipse. Notice how it's elongated up and down this time instead of horizontally. Now, I have not listed my vertices yet. Let's go ahead and do that. My vertices are these endpoints of my major axis. So notice this time my x-coordinate is 0. Y is either plus or minus 4. So my vertices are at 0, 4, 0, negative 4. That gives me a major axis of length 8. My minor axis has a length of 4, using B equals 2 to go from the center each way. Now, again here, if I want to locate my foci, C squared equals my A squared minus B squared. So this time, my A squared is 16, my B squared is 4. So that gives me C squared equals 12. Now, that's not a perfect square. C will be the square root of 12. We can simplify the square root of 12. Since 12 is 4 times 3, we get 2 times the square root of 3. Now, my foci will be on my major axis, so that means they're going to be up and down like this. So my x-coordinate is going to be 0. My y-coordinate will be plus or minus 2 times the square root of 3. Now, this gives me the exact value of my foci. If I need to find that on my graph, what I'll do is use my calculator. 2 times the square root of 3 is approximately 3.5. So if I go up on my y-axis, 1, 2, 3.5, notice my first foci are going to be very close to my vertices. I couldn't say that. And then down about negative 3.5 gives a rough location of those foci. Usually when you're asked to give the coordinates of a vertex or a focus, you should always list the exact value as far as listing that, but then to locate it on a graph, you can certainly use your calculator and approximate that. Now, we've looked at 2 examples here where the equation was already in standard form, and we were just locating our values of A and B and using that to sketch our graph. You've seen if the larger number is under X, then our ellipse is elongated horizontally like the x-axis. If the larger number is under y, then our ellipse is elongated vertically like the y-axis. Now let's look at another equation that is in fact in standard form, but you're going to see that our a squared and b squared are not perfect squares this time. Find the vertices, length of the major and minor axes, sketch the graph. Look at your equation. X squared over a number plus y squared over a number equals 1. Now, 8 is my larger number, isn't it? My larger number is under x, so I will be elongated horizontally like the x-axis. A squared is 8, so a is the square root of 8, which I can simplify. 4 times 2 for 8 gives me 2 square root 2. Now I'm going to go ahead and do that with my calculator to find an approximate value. 2 times the square root of 2 is about 2.8. So I'm just going to put approximately 2.8 to help me locate that value. So from the origin, I'm going to go about 2.8 to the right and about 2.8 to the left. That locates my vertices. Let's list our vertices right quick. Our vertices are on the x-axis, so my x value is plus or minus 2 square root 2. My y value is 0. Now, my major axis length, let's just list that. I'm just going to say major axis here. A is 2 times the square root of 2. Remember, the length of my major axis is 2 times A. 2 times 2 square root of 2 gives me 4 square root of 2 for the length of that major axis. Now, b squared is 5. So b is the square root of 5. The length of my minor axis is 2 times b. That would be 2 times the square root of 5. Now, to locate the endpoints of that minor axis, let's find the square root of 5 on our calculator. The square root of 5 is about 2.2. So I'm going to go from the origin up 2.2 and down 2.2, and I'm going to use this to sketch in my ellipse. Now you'll notice this time that it's almost circular. Why is it almost circular? Look how close the value of A is to the value of B. A was about 2.8, B was about 2.2. I didn't write that down here, but if you compare those, they're not very different. The closer A and B get to each other, the more circular your ellipse is going to look. Now, let's just find C right quick. C squared, remember, is our A squared, which is 8, minus our B squared, which is 5. 8 minus 5 is 3. So C is the square root of 3. And so our foci, being on the major axis, would have an x coordinate of plus or minus square root 3 and a y coordinate of 0. And of course, again, you could go to your calculator and get the square root of 3, which is about 1.7. So about 1.7 and negative 1.70 would be those foci for this one. Now, let's look at an equation that's not already in this standard form. Find the vertices, the length of the major and minor axes, and sketch the graph. Now, he's sort of hinted here that we do have an ellipse. But let's talk about how would I know that if he had not instructed me here to know that I was looking for a major and minor axes and that sort of thing. Look at this equation. 4x squared plus 9y squared equals 36. Notice that x and y are both squared. They have different coefficients here, but they are being added together. So what we're looking for, as far as the equation of an ellipse is concerned, is to have x squared, a plus, and y squared, but these coefficients will be different. Recall that when you have a circle, you have x squared and y squared, but the coefficients are the same. Now, since these coefficients are different, I'm expecting an ellipse, and I know if I'm expecting an ellipse, I need x squared over a number plus y squared over a number equals what? 1. Now that 1 is the key here. In order to get a 1 out of 36, I need to divide by 36, don't I? That'll make 1. But if I divide the right hand of my equation by 36, I also have to divide the left hand side of my equation by 36. So let's do that division. Remember, it's always okay to divide both sides of the equation by the same number. Well, notice here, 4x squared divided by 36 will reduce down to x squared over 9, simply reducing the 4 and the 36. And then the 9y squared over 36, when we reduce that, we get y squared over 4. And notice we get our 1 over here. Now, while we're talking about putting this in standard form, I also want to remind you that in that form of the equations that we looked at, let me slide that back up here. Notice up here on top we have x squared. What's in front of x squared? Not anything. That means it's a 1. 1x squared, 1y squared over these numbers. 1x squared, 1y squared. So we cannot have like 2x squared or 3x squared or anything like that in our equation. Now, having put this equation in standard form, we can see our larger number is 9, which is under x. So a squared is 9. So a is the square root of 9 or 3. So my vertices, since my larger number is under x, is going to be on the x-axis. So I will go over 3 and 3 this way. My vertices are at plus or minus 3, 0. My major axis then will have a length of 2 times 3 or 6. B squared is 4, giving me B equals 2. So my minor axis will have a length of 2 times B. 2 times 2 is 4. So since my B is a 2, I'll go up 2 and down 2 and use those points to sketch in my ellipse. Okay? Now this time I'm not going to go ahead and do the foci, but you could certainly do that using your a squared minus b squared here. So if your equation originally is not in that form, if you can recognize you're going to have an ellipse, then you might need to divide to get your 1 over here. Find the vertices, the length of the major and minor axes, and sketch the graph. Now again, he's telling me ahead of time, but notice here I have x squared and y squared. They're being added, but I have different coefficients. So that tells me to expect the ellipse. I need to have x squared over a number plus y squared over a number equals 1. So I'm going to divide by 6 on both sides of my equation. Now let's see about reducing. Now 4 over 6, these do have a common factor of 2, don't they? 2x squared over 3. Now here the 3 and the 6 will cancel. I get 1y squared over 2 equals 1. Now my problem here, I do have my 1, I do have y squared over a number, but notice I still have a coefficient in front of x squared. And we just talked about I have to have 1x squared there. So I don't want to divide my whole equation by 2 because then I would get a 1/2 over here, which I don't want to do. I don't want to mess up that 1. So since the 1 is okay and this term is okay, I only want to work on this term over here that's not quite right. Now you'll notice this term is in the form of a fraction. If you have a fraction, it's always permissible to divide the numerator and denominator of that fraction by the same number. Since I don't want that 2 there, I'm going to choose to divide the numerator and denominator both by 2. So in this numerator, if I divide by 2, I get 1x squared. Now in the denominator, if I divide by 2, since 3 does not divide by 2 evenly, I'm just going to write the fraction 3/2. Okay? Now I'm going to recopy my y squared over 2 equals 1. I now have x squared over a number plus y squared over a number equals 1. There's nothing in that definition that says my a squared or my b squared can't be a fraction. Now let's look at these numbers. 3/2 is equivalent to 1/2. So 2, the number under y, is larger than the number under x. So my a will come from that number. A squared is 2. So a is the square root of 2. The square root of 2 is approximately 1.4. My larger number being under y says my ellipse is elongated vertically. So I'm going to go up about 1.4 and down about 1.4. That will be my 2 vertex points. So my vertices have an x-coordinate of 0, My y coordinate is either plus the square root of 2 or minus the square root of 2, so I'll list that. My b squared is 3 halves. So b is the square root of my 3 halves. I'm going to write that as the square root of 3 over the square root of 2. And I'm going to go ahead and rationalize this by multiplying numerator and denominator by the square root of 2. So the square root of 3 times the square root of 2 is the square root of 6. And the square root of 2 times the square root of 2, of course, gives me 2. Now I'm going to go to my calculator and take the square root of 6 and divide by 2. That gives me about 1.2. This is approximately 1.2. So on my x-axis, about 1.2 each direction. Notice again, we're going to be almost circular because the A and B are so close together. But I'm elongated a little bit more on that y-axis than I am on the x-axis. Now, my major axis length is 2 times A. My A value is the square root of 2, so 2 times the square root of 2 will be the length of my major axis. My minor axis has a length of 2 times B. B is the square root of 6 over 2. If I multiply 2 times the square root of 6 over 2, these 2's cancel. My major axis has a length of the square root of 6. Again, you could find your foci. It will be a little bit more difficult here because you'd have to deal with these fractions, but it could certainly be done. Remember, foci, c squared equals the a squared minus the b squared. Find the vertices, the length of the major and minor axes, and sketch the graph. Notice again, I have x squared and y squared. They're being added, but I have different coefficients. Now this equation is interesting because notice I already have a 1 over here. So I don't need to divide to get my 1. So what am I going to do here to get this x squared over a squared plus y squared over b squared form? Well, all I'm going to do is take my equation and I'm just going to write x squared over 1 and 3y squared over 1. Now I at least have it in the fractional form. But notice this is sort of like that last example. What's wrong with this? I can't have that 3 in front of y squared. This form for x squared is okay. X squared over 1 plus. Within this single fraction, I'm going to divide the numerator by 3 to make that be y squared. Then if I divide my denominator by 3, I get the fraction 1/3 equals 1. Now 1 is larger than 1/3, so my a squared is 1, and of course the square root of 1 is 1, so a is 1. And b squared is 1/3, so b is the square root of 1/3. Well, the square root of 1 is 1 over the square root of 3. Let's rationalize. And so b turns out to be the square root of 3 over 3. Now, since my larger number 1 is under x, I think I'm going to change this scale a little bit. I'm going to count over and let this be 1 and -1. So here's 1 and -1. Now, if I take the square root of 3 and divide by 3, that's about 0.6. So a little more than halfway between 0 and 1 on my y-axis. And here's a quick little sketch of my ellipse. Now my vertices are on that x-axis since my larger number a was under x, so my vertices are at plus or minus 1, 0. My major axis has a length of 2 times a. 2 times 1 is 2. And my minor axis has a length of 2 times b. Well, 2 times the square root of 3 over 3 could be written 2 square root 3 all divided by 3. So I have my vertices, my major and minor axes, and the sketch of my graph. So in this case, because I already had the 1, I just made these look like fractions by drawing the line, putting those over 1, and then I needed to rewrite this one individual term. Dividing numerator and denominator here both by 3 gave me my 1y squared that I needed there. Now at this point we've seen how if we have the equation of the ellipse, then we simply need to be sure we have the standard form of the ellipse, identify a and b, and use that to sketch our graph. Now, this next problem that we're going to look at is a little bit different. We're just going to be given some information about an ellipse, and it's asking us to find the equation. Let's take a look. Find an equation for an ellipse that has its center at the origin, a major axis of length 10, minor axis of length 6, and foci on the y-axis. Well, let's see. If the foci are on the y-axis, that tells me our major axis is vertical, right? Remember, the foci are always on that major axis. If my major axis has a length of 10, then from the center I need to go up 3, 4, 5, and down 1, 2, 3, 4, 5. That would be where my vertices would be. My major axis has a length of 10. My minor axis has a length of 6. So what would I do? I would go left and right 3, wouldn't I? To get a length of 6 across here. I can sketch in my ellipse based on the information that we're given here. But notice I wanted the equation. Well, we know our equation is going to be x squared over something plus y squared over something, equals 1. I was going to say 1 and wrote a 1. Let's play like I didn't write anything yet. X squared over a number plus y squared over a number equals 1. We just need to decide what these numbers are. Well, again, our major axis has a length of 10. What does that tell you? The length of the major axis is what? 2 times a? If 2 times a equals 10, then a is 5. This is my larger number. A squared then would be 25. Where does that go? It goes under y, doesn't it? Because my foci being on the y-axis, since I'm elongated vertically, my larger number goes under y. Now, the length of my minor axis is 6. Remember, 2 times b gives us the length of the minor axis. So 2 times b is 6. So b would be 3, making b squared 9. That 9 will have to go under our x squared. So with this information, we were able to write the equation of the ellipse. I hope that these examples have given you a basic understanding of ellipses when we have the center at the origin. If you really concentrate on the concepts that are given in this tape and learn those, then it's a very easy process to take this and generalize to an ellipse where the center is not at the origin. Let's review the basic concepts. Our equation is x squared over a number plus y squared over a number equals 1. That's the standard form of that equation. A squared identifies where our vertices are. A squared is our larger number. We take the square root of a squared to get a, and that will locate our vertices. A gives the distance from the center to a vertex. Also, the other number, b squared, if we take the square root of that and get b, b gives us the distance from the center to the endpoints of our minor axis. The length of our major axis is twice a. The length of our minor axis is twice b. If you're required to find the foci, we use the equation c squared equals a squared minus b squared to find c. C gives us the distance from the center to a focus point. And remember, the foci are always located on that major axis. Thank you very much. If you're finished with this tape, would you please rewind it?